Hi, my name is Aaron Curtis. I'm in Group 1. Coming up next week, I believe the teacher switched me to Group 3, so this may be my last presentation. But this week, I will always be the same chapter, but this week it's on Chapter 3. It was the second way, and it's the principles of feedback is essentially what the second way is. Um, Similar to last week, I'd like to start out with a couple of definitions. Merriam-Webster defines communication as a process by which information is exchanged. The full definition is slightly longer, but that's the gist of what communication is. It's an exchange of information, meaning there are two parties. Feedback and feed forward, it's a transmission of evaluative or corrective information and then specifically when it comes to DevOps, it's to both the left and right, or it's the communication, exchange of information between dev to ops and then ops back to dev. Another important term, especially in this chapter, is swarm. It's mobilizing of whoever is required to solve the problem, whether it be from the lowliest intern up to the president CEO. Whoever is required to solve a problem will be brought in. We've got this, I've included this little graphic here talking about that kind of shows the second way, the feedback loops. A few more terms, definitions. First way, just as a reminder, it's the principle that enables a fast flow of work from left to right. Then the second way is essentially completing that loop. It continues on with fast flow of information from left to right, but then it also includes the flow of information from right to left to complete the throughout the, and as it says, finish reading this, feedback from right to left at all stages of the value stream. So we have a complete loop here. And then another term that is talked about frequently in this chapter is complex system. The definition of a complex system is a system that defies any single person's ability to see the system as a whole and understand how all the pieces fit together. So more on the complex system, just knowing that a single person no single person can understand the entire system. An example that was included in the book is Dr. Charles Perrow observed the 3 Mile Island crisis, where a nuclear plant almost had a meltdown in New York, and he determined that there wasn't a single person that on their own was capable of understanding how the reactor would behave in all circumstances and how it might fail under any of those circumstances. Now, this is a picture of that complex system in a more technology-based situation. For example, right now, I work as a network engineer for a company, and we build massive data center networks for customers that are moving into our data centers. They're just, it kind of blows my mind when I see how large some of these networks are. And with as much routing and switching and firewalls involved, the security, the servers, there's no way that a single person can understand and know everything about this entire network. I can't do it. The design engineer that created it can't do it. There are some people that may know more than others, but no one's going to be able to know the entire thing. Now, in a complex system, it is important to realize that doing the same thing twice may not induce the same result. Testing the firewall rule from once may not induce the exact same result time after time after time. It's something to keep in mind and to recognize. Now, Dr. Stephen Spear cited 4 conditions to be able to work safely in complex systems. 1, the complex work needs to be managed so that problems in design and operations are revealed, basically so that you can see and find those problems. When a problem is found or notated or discovered that the problems are swarmed and solved. And we'll get into a little bit more about the swarming and solving in a moment. This local knowledge from resolving these problems is then exploited globally. So if you have a company that has 15 plants around the world, that one plant discovered a potential problem with their line number 4 in certain conditions, and they discover how to resolve that problem, that knowledge is disseminated among the entire company, so that problem, if it occurs with another plant, can be more easily resolved. Now, the fourth step is leaders create other leaders who continually grow these types of capabilities. This is important because we all know people move on, up, and out. We want to create an environment, create that buy-in to these conditions, so that they continue on and continue to improve and to be more efficient. Now, this is where we talk about efficiency. The same doctor, Dr. Steven Spear, excuse me, this was done by a different doctor, I apologize, but it was both a GM plant and a Toyota plant were observed and looked at for this problem discovery and problem resolution processes. And the GM plant had no plan for communication for the declaration nor resolution of any problems that were found or that occurred. In the book, it notes several times that vehicles would get off the production line and wouldn't have a steering wheel, or just plain simple wouldn't start, or engines were installed backwards. And these are errors that were probably discovered or seen at some point, but with no communication plan, no plan for resolving the issues, it just continued on. Now, Toyota had what they called the Anden cord. I'm not sure if I'm pronouncing that correct. There's a cord above every workstation in the plant. Anytime there was the slightest issue, whether it be from a lack of tools, a lack of parts, not enough getting backed up, not enough time to complete the task, etc. Any issue affecting the work, this cord was pulled. Management would have, in the book, it said 55 seconds to resolve the issue. If the problem was not resolved within those 55 seconds, the plant would shut down and everyone would swarm the problem and until it was resolved. Now, this sounds somewhat counterproductive in that it was that you shut down for sometimes a tiny problem, but initially it actually it may sound that way, but in the long run, it resulted in a much higher quality product, much higher productivity. The staff was learning more and better able to resolve issues much more quickly. And so in the long run, they became much more efficient, even though on occasion, hey, the plant shut down for what may be a pretty simple issue. But it turned into a very good experience and was a very good process. Now, swarming. Dr. Spear wrote, swarming is part of the disciplined cycle of real-time problem recognition, diagnosis, and treatment. It is the discipline of the assured cycle, plan, do, check, act. Through swarming smaller and smaller problems, we'll find defects or problems in the product much earlier. And I love memes. They're fun. I just included one here, a good old Tom Hanks, Forrest Gump. And you can go back and view the slide again if you'd like to read that. Now, culture and conditions must be created and permitted to allow swarm. The next point kind of follows up on that, in that creating the ability to swarm isn't enough. You have to continue to persist and to grow and the conditions that allow the swarm to begin. I worked as a technical support engineer at a company called Inside Sales.com. In our department, the technical support department, we actually started a swarming plan, I guess you call it. And what it was is the first level engineers, if there's a problem they couldn't resolve, they essentially would tag their ticket in a certain way that would alert a tier two engineer. The tier two engineers would attempt to help them. If they were unable to resolve that after a certain amount of time, it would then alert all of the tier two engineers and the managers. At that point, if no one was able to resolve it, would then go to tier three. And it just kind of was a progressive thing involving more and more people. However, one of the things that they noted quickly is that for this to be effective, the tier two engineers had to be available to be able to swarm to do this. And so they took a lot of their responsibilities that the tier two engineers previously had and reshuffled them to make it so that they would be more available. The swarming worked wonderful for several months. But then as higher ups started seeing that these engineers appeared to have time, appeared to be available quite a bit, they started putting more and more and more responsibilities on them, saying, hey, they've got time, let's get them to do this and that. Within a few months after that, it had gone completely backwards and they were no longer, there was no swarming anymore. So it's just something you need to create the culture, and you have to maintain it as well. Now, efficiency and optimization. The effectiveness of approval processes decrease as we push decision-making further away from where the work is performed. This is kind of known as bureaucracy, where someone 15 levels above you has to say, sure, you can do this, and then it has to leak all the way back down to you. We need everybody in the value stream to find and fix problems in their area of control as part of our daily work. And as one of the DevOps principles, automation of certain approvals and testing permit more effective and faster deployment of new code. Our most important customer is our next step downstream. So if I'm a programmer, depending on where I am in the process, my next step downstream may not be a production release. It may be to QA. It may be to another group of engineers. And that is who I am writing my code for at that point. I'm making sure that they're my customer, that they have everything they need to do their part of the job, that my code is written in an efficient way so that they can do theirs. In conclusion, Elizabeth Hendrickson wrote, and this is a quote from the text, it says, when I headed up quality engineering, I described my job as creating feedback cycles. Feedback is critical because it is what all allows us to steer. We must constantly validate between customer needs, our intentions, and our implementations. Testing is merely one sort of feedback. Once again, I love memes, and they all bring a good message. Feedback, and as the very first slide suggests, the second slide, excuse me, feedback is communication. It is the exchange of that information. I appreciate your time. I hope you have a wonderful day, and let me know what feedback you have on my presentation. Thank you.